just said, we're going to look at some formulas today and find areas and volumes with monomials, not necessarily with numbers, but with monomials. So if you look at the handout you have, you should have some figures that look like my figures. Do yours look like mine? The directions tell us to express the area of each triangle as a monomial. So we have a couple of triangles here on this first slide. I've given you the formula for the triangle on the board, also on your handout. But do you look at on your formulas page in your textbook? Do you see the formula for area of a triangle? So under the formulas, under area and triangle. Everybody see that? Point to it so I know that you found it. Again, that's just a good place you can find formulas if you need to. I've given it to you in this case. A lot of times on tests and quizzes like the EOC, they give you the formulas. They don't expect you to memorize those. Okay, they will give you a formula sheet, and this is usually one of them if you need to use it. They're more interested in can you apply this information rather than do you have this formula memorized. They want to know if you can use it. All right, so we're finding area. What does B stand for in this formula? Base. And H is? Height. In the first triangle, the one that's colored yellow, do we know the base?
Yes.
Yes. What is the base?
4x, 4
and the height is? 3x squared, y squared. So let's just use our formula and substitute in the information that we know. We know that our base is this number along the bottom. So we're going to put that in for B. 4x to the 4th, y to the 5th. Move this other triangle out of the way. And our height, h, is 3x squared, y squared. Could you simplify this? Yeah, we should be able to. There's a property that we've been using. It's called the commutative property. Because we can multiply in any order we want. So I might rearrange this to put all my coefficients in front. Put all my variables, my x next, and my y's. So let's multiply those coefficients. Half of 4, or half times 4 is 2, and 2 times 3? 6. What do we do to these exponents on the x's? Add them. 4 plus 2 is y to the 7. Add those exponents. Now, it looks funny because we don't really know what the area is, do we? Now, x and y are going to be numbers. We just don't know what those numbers are. Area is measuring square units. Do we know what units we're using here? No. How important is it to put a unit on it? It is. If we did know the units, we would need to put that on there. In our case, we don't know. So let's just write units squared, or square units. Though we don't know the specific unit type, we can label it as square units. Let's look at the second triangle. Again, we have, it looks a little bit different, but do we know the value or the length of our base and the length of our height? We do. Our base is 2cd cubed, and our height is 5c squared d to the 6th. Again, I might use my commutative property to rearrange. So then let's multiply those coefficients. Half of 2, or half times 2, 1, and 1 times 5 is 5. C to what power? The third. 1 plus 2 is 3. D to the 9. 3 plus 6 is 9. Again, we don't really know what units we're using, so we can label this as square units. Okay, on the second slide, we're talking about volume. Let's look at our back cover there. This first picture, what would you call that? A cylinder. Do you see the formula for volume of a cylinder? Put your finger on it so I know you found it. Volume of a cylinder. There is one for surface area, so make sure you're in the correct section. Alright, so what is that? Hold on, keep over your shoulder here. Okay. I'm going to write down that formula. Go ahead and copy that down if you want. V for volume equals pi times the radius squared times height. And you guys already knew that R was radius and H was height. Alright, so let's substitute in to our formula. Now we're going to square our radius. What is our radius?
2xy.
2xy. Did you remember to put that into parentheses?
Yeah.
We're not just squaring the y, we're squaring that whole expression. So I'm going to put it in parentheses. And our height? How tall is the cylinder?
3xy.
Yeah. It's kind of laying on its side. Think of it as a soup can laying on its side. The height is 3xy squared. So let's go ahead and simplify. Now we have an exponent to take care of. 2 squared, x squared, y squared. I'm going to evaluate 2 squared. 2 squared is 4. Bring everything else down. And now I'll use my commutative property. Now pi. Pi is really a number, isn't it? It's 3.14. But I want to leave it as pi. I'll leave it as pi. So 3 times 4, if I multiply my coefficients, 3 times 4 is 12. I'm just going to write that as 12 pi. Pi is a number. Yes, I know it's 3.14, but we're going to leave it as the symbol pi. X to what power?
3.
The third. Y to the fourth. So measuring volume. So what units do we have here?
Cube.
So we'll say cubic units. Let's look at our next picture. What shape are we looking at?
A cube.
Not technically a cube, because a cube up there.
It's not the same one else.
Is this a cube?
No.
How do I know it's not a cube?
It's longer.
Inside.
And the length of it.
Are the length, the width, and the height the same?
No.
No. What about these? Are these cubes?
Yeah.
Can you make these for me?
You're good.
dad. My dad's into woodworking. Talked him into making me some blocks. I have a plan for those, I just haven't made it yet. But those are cubes. How do I know that's a cube? All the sides are the same. Okay. Is our figure a cube?
No.
Are all the sides the same? No, they have different expressions for the length, the width, and height. So it's not a cube. What else could we call it? A rectangular prism. Do you see the formula for rectangular prism? Should be. It says prism. It doesn't necessarily have rectangular prism, but prism. Do you see that? V equals capital B times H. Now let me ask you, does that capital B the same as like lowercase b for base?
No.
You might know what it stands for. It means the area of the base. The area of the base. So the bottom of this prism, could we find the area of the bottom of the prism? Well, sure. How do we find the area of any figure? Length times width. Length times width. So base B is really length times width. Okay. That's what big B is really standing for, area of your base, which is length times width. So technically the volume is length times width times height, and that's probably what you've heard it referred to as before, am I right?
Mm-hmm.
So let's substitute into our formula. We're going to use L times W times H. What is our length? And really, let me just tell you, it doesn't matter what you call length, what you call width, what you call height, correct? Because you could flip your cube or roll it over, and your length, width, and height are going to change. So I'm going to call this my length. We'll call this our width. And then this will be our height. So our length is 3x cubed. Our width is 2x squared. And our height is 5x. Okay, so let's use our commutative property to simplify. 3 times 2 times 5 times x cubed times x squared times x. 3 times 2 is 6, and 6 times 5? 30. X to the what power? 6. 3 plus 2 is 5 plus 1 more is 6. 30x to the 6. How do we say that? Units cubed. How different is this than what we were doing before?
A lot.
A lot.
A lot?
Something is just
Somewhat.
It's just with shapes. We're just finding using a formula. But essentially, the rules are the same, right? We're still using power to power. We're still multiplying our bases out the exponents. The PMA part, that's still the same. We're just applying what we know.
Why would this be 33?
You multiply your coefficients. Don't add the coefficients. You multiply 3 times 3 is 6. 1 times 30. Well, I think you don't actually say 6. If you wanted to say 3x, it would have to be like x plus x plus x. That would be 3x. All right, I'm going to stop here. We're going to practice some problems. You know better than that.
I'm pretty sure we don't have to practice those.
I was freaking out the day that we did the user against his work. When we came back to school Monday, I was freaking out.
We're on page 405. 28 to 56 evens. Those are problems like we've been doing the last couple of days. And then 58, 59, and 60, those are going to be like we did today, where you're going to have some formulas, some figures. You're going to have to use formulas to find area and volume.
I hope y'all not